Hi, it's sparxUK here again. An exciting PCB from Matt Harlum. Whatever he produces is usually amazing. I like this already. I like the rounded edges there. That's quite cool. Matt has kindly sent this. He sent a few of these to the people in my Discord, so a few guys that work on these kind of things. They've got, 2000, 3000, 4000 to test this in. It's a Zorro card. Zorro 2, I think, for the Amiga 2000, 3000 or 4000. So it's called Ripple IDE. You can see we've got two IDE sockets there. This is going to be hopefully really cool. Those caps are really low profile, aren't they? And you can see it's been sort of partially pre-assembled. There's nothing on the underside there. But on this side we've got the jumpers here, and we've got 3 buffer chips there, 245s presumably. A position for a CPLD, so he's kindly, Sparks actually included this, CPLD, thank you very much Barry, and it was Barry that sent this out to me. It was just easier for Liv to, Matt, to send them to Barry, and then Barry could distribute here. He's like the UK distribution centre for my Discord. It's really cool. And we've got a space here for flash ROM, so again Barry, sparxUK, has provided one of those. So I'll have a look at the part numbers on those in a minute. It's the same chip here that we used on the Bluster, that Matt used on the Bluster, and that Stephen used on the TF520 actually, and the 534 I think he used one of those as well. We've got a regulator there to give us our 3.3 volts, a couple of caps, we've got a fuse here, look. More caps, tantalums by the looks of things, those. And some little resistors up there and over here. So yeah, in terms of assembly, well, it's not going to take long, this, is it? This might be my shortest video yet, unless we run into problems. Now, there are a couple of modifications I need to make to this as well, but looking at the photos, I think I can get these on first, and then I can do the modifications, and they just involve like cutting the trace and sticking a wire across. So this is obviously a proto, and there are just a few little teething issues there. So yeah, without further ado, let's get this flash ROM chip out. Yeah, so the chip is there. It's got a bit of flux on this. I think Barry may have used this at some point, and it may even be pre-programmed for me, which will be really nice. But you can program this in situ. LIV2, Matt Harlum, has written some software for this, to test it and stuff, and to program this chip. So you can program this chip up from the Amiga once it's plugged in, I think. Yeah, so the pin 1 marking on the silk screen is down near the regulator here. So the writing wants to be upside down, according to the way we're looking at it here now. Really fine solder points. I mean, not dissimilar to that actually. It's going to be the same pitch as the CPLD. Now, I think trying to get this on is going to be pretty hard actually, because the pad size is tiny. I mean, really, really tiny. It's going to move. This is going to move when I do this, even with the smallest tip. Hot air might be. Oh, you see, I've moved it. Hot air might be a thing here. Let me just try and solder at one point. Like that, just by holding it. And then inspect this side here maybe. And do the same sort of thing, just rotate round. Try and do diagonal opposite point. It's not so bad when it's a two-sided component like this, just two sides. If it's 4 sides, holding it like that and just doing it one pin, may not work. That's secure now. So it's secured up here, it's secured up there. So that's that anchored on. We'll get the CPLD anchored on as well, and then I'm going to use the Antex. Now, I do have a new tip that I've just never got around to showing, that has come from the amazing guy in Denmark, I forget his name of, not Stefan, another amazing guy in Denmark. Yeah, this is another one of these videos where, sponsored by NordVNP, technically. LIV2 falls into that category at the moment because he's in Sweden. But yeah, he's on his way back to nearer to home, New Zealand soon, I think. So hopefully that all works out well, and he's able to get to New Zealand as well. I'm sure he's stuck onto that tape. And I think Sparks may have pre-programmed the CPLD. Yeah, trying to rotate it with these 4 caps like that already soldered on is not easy, because the caps get in the way. It's funny, I've soldered this style of chip, this size, the exact package so many times, and when I see it like this now, first time in a while, and it's not been that long. I built a Bluster the week before last, but when I see the pitch like this, I'm like horrified at how small it is, how small the pads are and the pins. and trying to, let's say this side's out now, trying to get everything lined up is easier said than done. What I need to do next, I think, is get the amazing microscope that was donated by Kavanos out. That would make this easier, but yeah, I try and do things, well, I was going to say in order. This is not an order because this has just come in, but LIV2 wants some feedback on these, like, really quick, so I'll do the Kavanos microscope thing next. I have been looking forward to that microscope because it may open up other things to the channel, like being able to have a go at fixing more modern devices. Anyway, let's just try it and add a tiny bit of solder down here. See, I'm touching already, hang on, touching the pin. Oh, you see it's moved. This is the difficulty. Yeah, you see now this bottom side's out. This is what I absolutely hate about these small devices. Yeah, and of course you could use blue tack or something like that to try and secure something. Yeah, there we go. I've just about managed that, I think. That's going to be fine, so I'll just anchor it down here. So I mean, I was able to move it around with my finger there and then just sort of position it. I have to avoid this plastic connector here. That's it, and of course before you commit to solder all the rest of the pins, make sure your pin ones are right, and yeah, just make sure the pins are all on the pads. Yeah, the pin over here is kind of, oh, it's lifted up. This pin here is lifted up, I think. I can't see now. No, it's not. We've got a pin missing. Oh, I don't know what's going on there. It's lifted up. Yeah, there we go. And we're using the Antex here, but as I said, we'll move on to that new tip at some point. I just want to show that video, and I should have done it years ago, like 2 years ago or something, because I got it, it was sometime around COVID time, I think, he sent me that tip. But I still haven't used it, but I will do soon. I'm going to try and show some of this with macro or something in a minute. Anyway, let's just start down here. I'm going to just bob in, remove the solder from the tip, because we've got more than enough there. I've got a big blob here where it's joined those 4 pins. I'm going to slide this way, and I'm touching the end of the pad rather than the pin. And that's what you've got to do. If you go across the pins, you get big blobs like that. I'll try and stay away from that. Connect to there. Yeah, so I've got a little bridge there. I don't know if you can see that. There's a little bridge with about 3 pins. But just a little bit of rotating it around here and slide that way. Still got the blob there. Just trying to remove it. I'll be able to do this without braid. No, we do have 3 pins joined on the end now. You can move it around like that, sometimes that helps. There you go. There we go, got rid of it without using braid. So just one final frag here. Yeah, I am heating that cap. I mean, that's one of the things with having pre-assembled boards that got caps and things on, it can, you know, just inhibit access. So you can see there though, even it's a bit fluxy, yeah, it's okay. So I just need to do the same thing on the other 3 sides. Right, that's it for the CPLD. That did take me, had about 4 or 5 minutes if I'm honest. The capacitors around that made that quite difficult. You know, the 4 caps here just made getting at that point there where the cap is quite challenging. Right, so I got some more flux around the flash ROM, get some solder, use my magnifier again. Yeah, there's a cap there which is going to be painful. Here though we're alright, I think. Let's start in the middle. Just because I can't remember where I anchored it on this side. Going to just see if we can redistribute that bit of solder. There we go. And slide that solder all the way up there. remove it from the tip, back the other way again, hang on. Remove it from the tip. If you just go forwards and backwards like this, you've got 3 pins bridged there now. It's not getting better, is it? It's getting worse. Two pins bridged now. Yeah, I've still got 2 pins bridged there. There we go. Alright, the final clean up now, and then I can go and, well, I don't know, program maybe? I get the feeling I'm not going to need to program. So, just inspect with magnification now. Yeah, there's a bridge on this first 2 pins. So filming this bit right at the end on the Cavanos cam here, the video for this will follow. The modification I had to do to cut this trace here, yeah, from this pin, like it joined and it went all the way over here somewhere. The point being is you don't need to do this anymore, so it's kind of irrelevant, it's not that important. And LIV2 worked this out to cut that trace and put a 10k resist between that pin there and that pin there. So you can see, yeah, it's kind of not ideal size there, but anyway, that pragmatic bodge works okay. And as I say, the new version, which you'll also see in this video, takes this mod into account. You know, the fix has been applied to the later revision board. So there is another mod we need to do to the other side, I think, next. Yeah, and actually, I'm not going to bother with the next mod. The next mod is the IDE LED. I think it's like centre negative or centre positive or something, and it's the opposite of what it should be on the 2000. But you know what? The 3-pin connector, you can just overhang it on the wrong side, flip it round the other way, and it's going to work no matter what. In other words, as long as you don't got all 3 pins on, it should work, I think. So what else have we got here? We've got a key thing here. Does that need to be... yeah, key power. So I think we need a jumper on there so that this powers that, and there's one of these for each side, so I'll get a jumper on each of those. That's a disable jumper to disable it, and then just the JTAG header. So you know what, we're done, aren't we? I can go and get the 2000 on the bench and maybe give it a try. Now normally you'd obviously program this up, connect your JTAG header here, go program it. I might just do that anyway. I'll speak to Sparx. If it's already programmed that, I'm not going to bother because there's just no point. Right, so plugged in, powered on, going with a straight 68k, holding both mouse buttons down on boot, and you can see it's there, manufacturer 5194, product 5, working. So yeah, he's kindly pre-programmed that for me. But always go back to your basics when you're testing something like this. You know, I did have the you know, the 386 or the 286 card in here, and the TF536. Well, you know, I could kill one of those things, or it could complicate matters. So yeah, we'll start with the basics here, and let's get an adapter in. I need to go get a jumper down to power this, because at the moment we haven't got the jumpers on. I've got to hope that this is keyed the right way. I can't imagine it wouldn't be. I'm tempted actually to try that without that in, because then I switch it on. Yeah, see, there's no LEDs at the moment. I'm going to go with some nice white jumpers here, just because they, well, they give a nice contrast, don't they? Stick one there, and one over there. Again, not having this in, just in case there's a problem here, and I'm just looking at the LEDs. Yeah, red one's on. So that's now powered. And if we get this in here, that's it, switch it on. Green LED's on. So let's just see what happens. Yeah, just come up with that. Switch it on. So yeah, we've got a problem. Now I could try a different compact flash card. Let me go and get another one. So I've got this one here, which that's for 1200. I'm not going to boot that. I'm at 68k. Let's try this. This is one that may work. Yeah, no flashing on the LED. I'm thinking actually that flash one may need flashing, but the CPLD doesn't need anything doing because obviously it is detected at the moment. Right, so I booted up using the TF536 here, and I was able to see the card, yeah, but not the compact flash card in here, yeah. So in other words, it's working, it's detected. It's not presenting the drive though. In fact, that's not booting now. I've just taken this out though, so it probably just needs to go back in a couple of times. I always have this problem with this compact flash adapter here. Yeah, so LIV2's given me a floppy disk that's got the flash software on it. I've copied it to this compact flash card. I hope that's now not corrupted. No, it's booting now. Yeah, so I'll have a go at trying to flash the ROM, and it may contain some diagnostic information. Yeah, I stopped talking there because I was like, why is it paused? But it is actually working. So if I look at boards here, yeah, there we go. The Zorro 3 is the 536 and the 128K is that ROM for the IDE Zorro 2. Manufacturer 5194, so that's all okay. Get the shell up. Navigate to that folder. Hang on, this is where you need quotes if you've got spaces in any path. And it's LID flash. Yeah, thanks to Liv for giving me the parameters, but I spotted them in the startup sequence on the floppy image you gave me. LID.ROM. Maybe it was I, not L. It looked like an I. An L rather, in Discord. Found, IDE, erasing, writing, verifying. So it's done that bit. So let's switch it off. Let's remove this again and stick this back in, because then that's the only IDE in the system. And you'd hope it would work. Yeah, pin one at the bottom, switch it back on. Nope, it's just come up with a sticky disk in screen, so oh, what a pain. Right, so not getting anywhere here. I tested connectivity all the way around the CPLD. There are connections between the pad and the pin, but not the pin next to it, all the way around. So we haven't got any shorts, we've got good connections. Right, so here we are, booted up again after messing with that Amiga kit blooming power thing. So LIV2's given me another BIOS to flash with, well, told me which BIOS to use here, can't distribute it. So we'll go into System, get a command prompt, and we're going to flash it with the octopus device. Well, that didn't work, did it? Why has it got a -D that it doesn't support -D? I don't know where he's getting these switches from. It seems to only support -I. Maybe he's got a different version. Oh, I don't know, it's really cheesing me off, this. I think he's got a different flash utility that's just compiled for that. So I'm going to have to go back to the PC and copy that one across as well. Right, so here we are again. I've created a LID1, copied the driver and the programming software into that, because I think there's a newer version of the programmer, the flash. So LID flash -D octopus .device. That's better. Verifying. There we go. So if that works, it's only going to work with a single thing. And when I say a single thing, I mean a single interface here, like the master, not the slave or something, because I think that's how these are split. So I don't think this supports 4 devices, I could be wrong. I think it supports 2 devices. They're just separated that way. So I'm going to try it with the stock 68K back in again. Otherwise the 536 will just complicate matters. So I'm just watching the LED on this side here. But I've tested this multiple ways like this, kept swapping it over, reseating the card, different compact flash cards, that's not good. Again with the sticker disk and screen, and it never looks at the IDE at all. Just for good measure, we'll do that as well. So I know you can't see the LEDs, but the middle one is yellow, and that's not flashing, it's not lighting at all. So at this point, Matt ironed out a number of bugs in the ROM and in the firmware here, and sent me some new JEDs, and we repeat this process quite a bit actually, worked through lots of different bugs and added lots of improvements to the performance of it. And in order to program it, I used this Xilinx programmer here. There will be a link down below to LIV2's tutorial there on using a Raspberry Pi to program one of these, which I would say is probably a bit easier. I know I've never done it, I've not shown a tutorial, a lot of the people do that, there's probably other videos out there for that. It's dead straightforward, but I like this thing, but this can be a bit of a problem. sparxUK, I think, got one of these recently. I had no end of trouble trying to get it all up and running, but I use Impact 10.1, and the connections here are all marked, you know, TMS, TDI, TDO, TCK, ground and VCC. Now you just plug that on, connect it to the PC, and something else to know. I did ask if a modification could be done to this to add a 5-volt connection, because there isn't one anywhere, and I wanted 5 volts, and the reason being, long story short, is that regulator there needs 5 volts, otherwise, you know, the VCC pin here, which goes to the top pin there, is monitoring 3.3 volts. Where is this board getting 3.3 volts from when you're programming it? Unless you provide 3.3 volts into that pin, as well as here, because the programmer needs to monitor it. You might be able to disable that in the software, but in any case, what I end up doing, as you'll see in a minute, is just soldering a wire. We've got this pin here, that's 5 volts, and I soldered the positive of my fly lead there, and then the black lead to the ground, which was the second pin down here. And then let's use this wire here to connect onto you know, the red and black wires you'll see in a minute, just so that the board gets 5 volts and grounds coming into this regulator, and then you've got the 3.3 volts, and then these chips here are powered, this can detect it, and all is good. What you do is you double click on boundary scan, and then you right click initialize chain, and it should detect the CPLD, as you can see in the screenshot here. And then you just go and find your JED file, and you click a program, and then do a verify. So a few of us have been testing this, doing the beta testing here. sparxUK, Pillock, and myself. I think Screamo's got one, Stefan, but he's not got all the parts. But anyway, we've been beta testing, and there were some issues. It wasn't booting initially, and after a little bit of work here today, LIV2's produced 4 or 5 different firmwares actually as we've worked through the problem, and I think he worked out ultimately was the bus reset. I'll stick some screenshots up. Matt scoped the bus reset, and yeah, it was bouncing pretty significantly after, you know, some forwards and backwards talking about different things, everyone suggesting various things we might want to try. And I swapped between boards actually, and the Rev 4 it was booting, Rev 6 it wasn't, so I'm like, well, it's obviously something to do with the Rev 6, what's the difference between the Rev 4 and the Rev 6? And to start with, I was suggesting maybe the C1 and the C3 clocks, because they're not buffered the same on the Rev, although I buffered one of them on the AGA multifix, they're not buffered the same. And then other things like DTAC, well, my DTACs are in line with each other now, so it can't be that. And the only other thing was reset, because I think on the Rev 6 boards they've got a Mitsumi PST type chip that does the reset, and I just wondered if that was the difference. But ultimately, Matt went scoping the bus reset and had a look at that, and it was bouncing. So the end result is I flashed the firmware, it's booted, we've actually booted from that card here. First boot on a Rev 6 now, it's working. And I tested it on the Rev 4 as well, and it's working. So the final thing here is just to revert the BIOS. So, I forget which one it is now, get rid of LID2, that was one of the test ones. He did some work to disable some of the overlay stuff apparently, and he's just undone that. He's kindly undone that today. He's so quick. Slide.rom. So yeah, it's nice that he's built this functionality in, so you can actually flash the flash ROM on the Amiga. I like that. Obviously, if you mess that up, you're not going to be able to boot from it, but you can always boot from another compact flash card and run this software that way. And he does distribute this on floppy. It's just because I've not got a Gotek, and we will get a Gotek soon for an external enclosure. Because you know what, it causes me no end of pain. What I have to do on the PC, I take the compact flash card, I use WinUAE, I mount that boot from that compact flash card ever. A drive set up as a, you know, one of the folders on my machine set up as a drive on that machine, and I can drag and drop files across, and that's how I got these 2 files on there, the ROM and the flash utility. Anyway, that's it. So let's now power cycle it. Yeah, and I'm moving you around this side so you can see my dodgy wire here that I used to power with 5-volt and ground, and there's the LED looks flashing. So it is booting. It wasn't doing that before. And I think the benefit of this ROM, actually thinking about it, I think he got rid of the crazy, he added a delay, some delay, like a, he said it was 3-second delay, but I was counting to 10 before it was starting to flash, so a combination probably of not having the floppy drive connected and that 3-second delay, and that 3-second delay is no longer there, so it's booted a lot quicker. And that's worked fine. So I am very pleased. Now with this configuration here, I've got like no additional RAM, I'll show you, hang on. We're lucky if we've got half a meg free here. When it eventually, there we go. Yeah, we've got under half a meg. And it's because of these drives and probably loading the ROM into fast RAM. We ended up with just 500k here, which is not a lot. Now I'll show you the benchmarks here on a stock 68k. It's obviously you're not going to get staggering benchmarks on a stock CPU. There's a limit there on the throughput that device, because it's probably using some sort of programmed I/O, PIO mode. Hang on, I clicked the wrong thing there, didn't I? Anyway, you can see it's a stock 68k. Look, 1 in terms of the rating there. Hang on a minute, is that frozen? Why is that? Oh, and it's not. It's just took ages coming back. Yeah, and interestingly, if you've got a Rev 4 that's not had certain modifications, you won't see 1 there. That'll come back lower. Certainly on the DTAC stuff, you need to do some of the mods that feature on something like this Rev 6 to get 1. That's something that I always wondered about. In all the time they've been working on these, I've noticed a difference in performance between the Rev 4 and the Rev 6. But as I've brought the Rev 4 more in line with this, we see the same thing there now. So I've got to drives and DH0. Click speed. So you can see that's using LID.device. So that's LIV2's own IDE driver, I think. He may have based that on something and done some tweaks to it. Yeah, 850k. So that's about right. If we had a SCSI card near, like an A2091, that's what we'd see roughly with a stock CPU. But that goes up quite a significant amount if we test it with a faster CPU. If we switch that off and we remove the stock 68k and bring in the TF536 here, get that into the CPU slot, switch it on. I might need to rejig the power connectors here because that Amiga kit sometimes gives me a green screen depending on how it's whether the connection is good or not. But yeah, that's booted. Flashed there. So it will now take a little bit longer as it looks at these drives on this card as well as that card. So I'm watching here. I'll tell you if this LED here flashes. Yep, it's flashing now. Now it's back to there again. So we've now got quite a lot of IDE here, haven't we? Because in theory you could run 2 drives from the 536 and you've now got 2 drives here, maybe 4, I don't know. I'm tempted to get, I haven't got one though, another adapter, get another compact flash card in there, but this is where this will be super useful to me in my Case 2000. I want to get another one of these if I can, I think. I'd love to build another one. Oh, hang on a minute, I've got a corruption. Yeah, can you see that? Validating more games. I hope that's not corrupted something here. Right, I booted from the 536 on its own, and I'm not getting that issue about validating different volumes there. Like it was saying that games was corrupt, storage was corrupt, all source was corrupt. So that compact flash card is okay. I'm now booting from this one. Let's just see if this boot's okay. I suspect it may do. Hopefully it's not corrupted. What's happening here, and I've seen this before. Yeah, that's booted, I think. Yeah, what can happen is you've got like duplicate drive names, volume names or whatever they are, drive labels, I don't know what the terminology is. So I think what we need to do is we need to go in here and we're going to need to go into HD Toolbox. It's always a good idea when you've got different devices that could coexist in the same machine with different drives to have them all on some sort of unique identifier. So on HD Toolbox here we need to change this to LID.device, I think, instead of SCSI.device. Yeah, and this is how you change this utility here to point to the right drives within your system, the right IDE controller. Let's try that, see if it detects the card. Please work. Yep, there we go. And what you do is you go into Partition, which seems like a worrying place to go. You go in there anyway, you go. You do it here. So this is the thing, we've got on the terrible fire card there, that's got a DH0. Because this is on the LID, I'm going to call it LH0, and then you've got to press return, not anything else. Change that to LH1. Hang on, uppercase LH1. And we'll click OK. And then we do save changes. Exit. I'll reboot just to make sure that works. So I'll power cycle it. And then assuming that works, we can then try the 536 again. I'll take the stock CPU out. Yeah, so it's starting to boot. And on its own it's worked okay, so let's add the 536. So I've got my fingers and my toes crossed here that that's not going to give me any corruption errors. And I tell you what, there's nothing worse than corrupting one of your compact flash cards testing, and it has happened to me on occasion. So, you know, I would say to you, use something like Win32 Disk Imager. I'll try and find a link and post that down below. You can use it on Windows 10. Do make sure you've got the right drives selected when you're using it, because the last thing you want to do is accidentally write over one of your system drives in Windows 10. Yeah, that's normal, because we've got 2 workbench volumes actually. That's the other thing. You might want to change the names of some of these if you've got 2 drives with 2 lots of workbench, but you can cancel, cancel, cancel. Now, interestingly enough, it's not showing the extra. Oh, yeah, it's because this is the other problem. It's not just about those, you know, the DH0 stuff. It's about these actual names. Because we've got 2 workbenches, it's not showing the second one. Yeah, so what I'd have to do is, like I say, is boot again with a stock CPU on the other compact flash card on the cider, you know, on the LIV2's interface there, rename all of these, then do all this again, boot back up, and we'd have a load of different drives. We'd have 10 drives here instead of 5, you know, 5 hard disk, or 4, is it? 1, 2, 3, 4, 5, yeah, 5 volumes on the hard disk, and you've got DF0s not connected and RAM disk. But nevertheless, that has worked. But you can still benchmark them, so you'll see what I mean. Go into sysinfo, what it does, and you could still do this if it managed to. Oh, I've clicked the wrong thing again. If this had managed to boot with the DH0 overlaps, which you can do, it doesn't always give you that corruption issue. What you would see here is DH0 and then DH0.1. DH1, DH1.1, and that's how I benchmarked it before. But now it's listed them here separately. It hasn't had to append the .1 on the end. You can see that it's using LID.device. So if we speed test that, this is where we'll see a big boost. Look at that, nearly 3 meg. Yeah, because we're using a 50 MHz CPU. I did have just under 3 meg before, like more than 2.9. So I'll give it a couple of benchmarks here. Yeah, you can see it's about 2.85 there. That's pretty damn good, really. Now, this compact flash card is going to have a bearing on that as well. So if I had a faster compact flash card, I'll bet that that would go faster than that. Yeah, and if you're curious, and I've shown this before, DH0, so this is using sparxUK TF536 IDE here. This usually comes up pretty blooming fast, look, 4.5 meg. But you see the difference there is you haven't got the Zorro limitation. It's easier to get a higher speed like that when the CPU, you know, a fast CPU like this 030, which can run at 50 MHz, can communicate directly with the IDE with nothing in between. So, you know, here with these LID drives, you've got the Zorro interface, the Zorro 2, in between, and there's probably like a theoretical max you could get out of that, like 3.5 meg maybe, or 3 meg. So I would guess if I had a better compact flash card, we could get nearer to that limit, but we're not far off it there. I'd be amazed if there's any of the, you know, the Buddha IDE, can you get about 2.8 meg out of it? I'm honestly not sure. Haven't got one of those to test. Might just ask the guys in Discord what they see from something like the Buddha IDE, but that is really good performance. Excellent, in my mind. Yeah, so testing with the TF520. The LIV2 RAM board here, currently set to 4 meg, and that card. Yeah, I'm occasionally getting these checksum errors, and this could just be the 520, you know, it doesn't like this card, I don't know. I'll experiment a little bit more with it. Yeah, so the TF520 was sulky with it, but you know what, it's sulky with lots of things there. It's better on the 500 than the 2000, the TF520, and it was a very early card. The A2630 here with 4 meg, and LIV2's card with 4 meg, they've got to go faster, 2000. And of course LIV2's Ripple here, everything is working fine. And I gave it the Beneath the Steel Sky test, which is a good one because it's huge. It's like, it takes about, I don't know, 5 or 10 minutes to load or something. And everything's loaded and okay, and it seems to be working. Yeah, you're not supposed to go down there, are you? Does that guy get you? I think he does. And then it's game over, I'm not sure. Yeah, look, he gets shot down. Yeah, he's supposed to pull like one of the little metal edges off or something there. But anyway, that worked. Let's see if we can quit out that with the keyboard. Yep. Yeah, and as you can see, we've got 8 meg of RAM. Bear in mind the Ripple has nothing to do with that. But the LIV2's of the card does. If we go into sysinfo, you can see what the performance is like. I mean, it's lightning fast here already. But if we go into drives and we do DH0, yeah, LID.device, so it's around 2.2 meg-ish, 2.1 nearly there, but it was showing 2.2, let's do another one. Yeah, almost 2.2. Bear in mind the 2630 is running at 25 megahertz, so you don't get much of a step up when you step up to the 536 in terms of the additional 25 megahertz there. Yeah, it was almost 3 meg with the 536, so it's probably getting near to the Zorro 2 bottleneck at that point. But here, yeah, just over 2 meg is not bad. Not bad at all. Yeah, so working really well. I think one thing I should consider doing actually is reflowing the compact flash adapter here, this. Just because there's been a number of times here where I'm getting, you know, block errors, you know, etc. You know, it comes up saying a read error, validation error, etc. And then I reset it a few times and it's alright. Likewise, when I was testing the 520, half the time it wouldn't even detect it. It was just flashing, it's like a single quick flash on the LED there. And then I'd reset it, and then it'd start to boot, and then I'd get like a validation on the games folder or something. So, yeah, I think it's this. When I first tested it here, it wouldn't even see it at all. A few times, just had the sticker disk in screen pop up, and then again I reseated it a few times, and I put contact cleaner in, and then it worked. And I think it's probably just this here needs a reflow, because, you know, they're awful, some of these from manufacture. So I reflowed that compact flash adapter there. And it seems to be better now with the other card, where it was sulky. Yeah, there's the odd pause and stuff like that because, well, we've got a shortage of chip RAM on this board, 1 meg. Yeah, so even though it's doing the preload thing, you get those little pauses like that if you've not got quite enough RAM of the right type. So I think for my own sanity now I've dealt with that. I'm going to take this back out, put the 536 back in. I'll leave LIV2's RAM board in at the moment. Got to go fast to 2000, just set to 4 meg, but it will work set to 8 meg because you can still have I/O that overlaps that area, I think, and the ROM on this can overlap, so you can still have 8 meg and this, even though it's got 120k ROM, I think. I mean, I would need to test all of the RAM range out that way, but from my experience testing that, it seems to have been that way. Let's remember to remove the 68k this time. So, through several revisions of firmware, and Matt was up till 2:30 in the morning, as of this morning, he's still there now, I think. Dedication for you, absolute dedication. The firmware on this now is solid for me here. I'm going to test it on the 4000 next, but that's flashed straight away. Didn't need a reset. Hang on, what's happening here now? It's looking floppy drive, I think. Yeah, 536 is continuing to boot. We don't get any issues with anything showing up corrupted or invalid volumes and all that sort of stuff. It just works. It works flawless. I tested it pretty significantly yesterday afternoon, and it's working fine. But he's still working on firmware because he still thinks he's got some sort of issue. I think there was a problem with the EATX 2000, the remake of the 2000. But, you know, I'll echo one of the comments that I posted on my Discord actually about that in relation to it. One of the things with that is they changed the 7.4 families, yeah? Like some of the buffers are using HCTs instead of the original LS or ALS. Yeah, I have ALS on all mine. And it's the same as some of the other 7.4 series on there. They've changed them, and it's like, why would you do that? As soon as you start changing 7.4 series logic families on a remake of a board, unless the reason you've changed it is because you've compensated for timing differences in other ways on the board design, and I don't know how you would easily do that. The problem is you're going to get timing differences, that's the thing, so it's no wonder. The EATX 2000, all I hear about that is this works so that doesn't, this works so that doesn't. These original 2000 boards, everything works on it, without exception, everything works on it. Yeah, so 7.4 series, you want to stick with the same 7.4 series families, unless, let's say, you've compensated some other way in the design to take into account timing differences for using different 7.4 series. And there might be margins there that you can work within to have some slightly different families and things there, I don't know, but anyway, that's the problem. What's that saying? If it ain't broke, don't fix it. Right, and I'm not being critical of the ATX 2000. I think it's really good that someone's recreated the board to deal with corrosion issues, but if you're going to recreate it, just recreate it. Use the same stuff. only tweak what needs tweaking. And to a degree, it may be that people have only been able to get certain parts when they've built them. But anyway, you can see we've got a load of volumes here. 5 hard disk volumes on each drive. 2 lots of games there. It's incredible. And just look at the difference, right? That's the 536. That was slower at opening. Now, let me just show you something. If I load Beneath a Steel Sky, I'm not going to load the CD32 version. I think you need 2 meg chip actually for that, and I haven't got that on this machine. But if we nevertheless load that, and I just watch how quick this loads. Watch the progress bar along the bottom. Now this is the fastest I've ever seen this on the 536, and it's because it's using the ripple there. It just zooms along. It's incredible how fast that goes. Now what I was expecting, I'll show you this if we quit out of that as soon as it starts. So that's loaded. If we load from the 536's compact flash card instead, that's slower to start with, and that's an identical copy of the drive. Yeah, it's got identical files. And if we benchmark the 536, it comes about 4.5 meg per second. The ripple are at just under 3. Yeah, same files, same exact files, it's just on a different compact flash card. Now this is a faster compact flash card. It's supposed to be giving us 4.5 meg. Yeah. Look how slow it's moving. It's like a pixel every second or two. At this point here where it slows down, I kid you not, I'll be waiting just under 3 minutes for that to load, probably, maybe 2 if I'm lucky. By now it's loaded on the ripple. It's incredible, isn't it? And I was talking to LIV2 about that, and he said that he thinks it's to do with, I think, one of the block transfer commands or something like that. He was looking at the ATAPI stuff, and I think he's supported some feature that instead of just doing, I don't know, small blocks at a time or a single block at a time, it can do like a larger transfer or something like that. I think that's the top and bottom of it. So despite the fact on sysinfo it benchmarks a lot slower, it's considerably faster. I mean, you could have almost loaded it twice now probably on the ripple. Yeah, anyway, that's definitely something that maybe the 536 could benefit from if a tweak could be done to the firmware for that. Anyway, trust me, that works really reliably and solid. I'm going to take this board out of the way. I'm going to bring the 4000 onto the bench. There'll be a separate video on this 4000 that you've not seen the repair of yet. As I say, there'll be repair. It's quite a considerable one actually of this coming up. There we go, it's booted. Yeah, so boot straight off cider. Yeah, did I say cider? I keep doing this. I keep thinking and remembering the original project was cider. That was for the CD-TV. But this, you know, is a derivative. I can't even say of that, which is ripple, not cider. Seemingly no problems accessing anything. Let's try Beneath the Steel Sky again. I'll have the CD32 version this time. So it's not going to load quite as quick because it's a lot bigger, the CD32 version. Yeah, and that worked fine, look. It did actually speed up quite a lot after the first minute or so. And the progress bar there doesn't go all the way to the end on that version. Now, it probably does. I think what you've got to do is in the tooltips for the, the icon, you have to set the preload size, and I think it's not set right there, which is why the progress bar was so huge. And it only went up about that much on the, I don't know, 20%, less than 20%, before it actually loaded. Yeah, so that's working. I'm curious to, let's just quit out. Oh, I haven't got a keyboard connected now. Let's just boot it again. And we'll run sysinfo on it. I want to see how fast it is. Right, here we are in sysinfo. Let's speed test that. It's not going to be the 3 meg, I don't think. Yeah, 2.131, because we've only got an 030 running at 25 megahertz here. I'm curious to maybe try the standard version of Beneath the Steel Sky that we loaded on the other machine, on the 2000, just to see how fast it actually loads there. So yeah, just over 2 meg, 2.2 meg. So I mean, that's certainly better than the stock IDE you get on a 4000, from my experience. I want to say the standard version. I think the standard version was not AGA, was it? It didn't need the 2 meg chip. I don't actually think there is an AGA version. The CD32 just needs 2 meg. But this version was OCS, you know, and it was floppy based. So there's a lot less data. Yeah, so that's even faster, isn't it? Or about the same. It's about the same as it was with 50 megahertz there on the 536 on the 2000. But the 536 wasn't doing the loading. Yeah, it's about the same speed. It's zooming along there. So he's definitely got that same, you know, performance benefit there from the, you know, a tappy command that he's implemented that just transfers things a little bit faster. That's very cool. Testing against LIV2's Gotta Go Fast Zorro 3. You can see we'll start at 280 meg there, so yeah, it's making use of that RAM, and it seems to be loaded. It's taking a bit longer because now we've got more RAM, so it's loading more of it into RAM. But before we only had 16 meg. I'm guessing that's going to drop down below 200 meg in a minute. It's interesting how that doesn't update very often when there's a lot of activity going on. There you go, just below the 200 meg mark. Sweet. Yeah, so after about, I don't know, 10 or more firmware revisions, LIV2's got this absolutely perfect now. It seems to be working for everyone, you know, 3000, 4000, 2000, different combinations of hardware alongside these things. You know, I had the 8 meg Gotta Go Fast RAM 2 in this LIV2's board as well, and his bluster. The 536, it goes without saying that I couldn't do a lot of these videos without the 536. The 536 is just absolutely amazing. Stephen has done an amazing job. Check out the link top right to the interview I did with Stephen last Christmas. But the reason I mentioned that is because without that, the 286 board here doesn't perform quite as well as it could do. You know, the IDE, this is really good. But the IDE on this, in some ways, is better. There's some sort of limitation on the 536 IDE that this card from LIV2 doesn't have. Beneath the Steel Sky loads, I would say, 5 times faster. Yeah, you watch the progress bar, that goes all the way up. If you benchmark this, it's just under 3 meg. This seems to be able to, you know, stream a continuous stream of data, whereas this sort of starts and stops and loads of little bits. But the 536 is really, really good. As is, well, the focus of this video here, the Ripple. It's amazing. You know, I've booted the 536 using that card, and I've swapped with other cards I've got here. So a wide selection of my compact flash cards work on the Ripple here. LIV2 is going to do a small tweak to the final version of this, just try and get this out. Yeah, that's one thing. It can be a bit hard to get out because it's such a low profile board. So you may stick some ears or something on it, or a handle or something to pull it out. But nevertheless, it's really impressive, isn't it? You did have the thought of trying to fit a third interface somewhere here. Maybe just a dedicated compact flash one or something. And then it would be a triple Ripple, which would be really nice. So yeah, it's so simple, but so powerful and easy to build. So the only modifications we had to do on this Proto here was, you know, to cut that trace, put a resistor there, 10k. And yeah, it just works. I'm really, really pleased with this. And reiterating, these jumpers here pass through the power to the card. You know, because this thing here has got an adapter. You know, put your 5 volts into here. And incidentally, some of these have got a jumper. This one's got one for 3.3 volts or 5, and there's just 2 diodes that, if you've got the 3.3 volt jumper set there, it'll feed the 5 volts through those 2 diodes. You get a 0.7 volt drop with each, and then it powers the card. So that's a bit fluffy on these adapters, and some of these compact flash cards like this may be one. If you were to take this to pieces and have a look inside, it's probably got like a 3.3 volt chip, yeah, even though it's in the 5 volt setting. So just note that when you buy some of these cheap compact flash cards, some of them are 3.3 volt, and whilst they work at 5 volts, they may not last forever, and you may get some sort of issue with them ultimately. And it could obviously risk damaging your interface when you've got a 3.3 volt device here and you're interfacing with 5 volt logic levels and things. That's so cool though. The other nice thing with this obviously is so much of this was pre-assembled by the PCB manufacturer. So all I had to do was fit the CPLD and the chip there. Both of those were provided kindly by Barry, sparxUK. So thanks for sending this off to me, Barry, and thanks for providing those things. So again, the video is getting a little bit long, so there will be a part 2, and we'll look at some different features. Just summarising here, I realise I should have covered some of this stuff at the start. Having a look at LIV2's GitHub page here for the LID ROM, which is, applicable. That's the ROM we're using here. Looking from the top there, you can see it supports auto boot, works with Kickstart 1.3 and up, supports 2TB drives, supports TAPI devices, CD, DVD, ROM, zip, disk, boot from zip or LS120, boot from CD-ROM. That's quite a cool feature. I'll try and do that in the second part. SCSI Direct, NSD, TD64 support. Yeah, so large hard drive support over 4 gig. As a default, OS 3.1 won't support that. I think you've got a 4 gig boundary, and there's more about that in part 2. So you need Kickstart Workbench 3.2, I think. And then there's a little bit on the bottom of his GitHub there about the hardware implementation, about the different IDE ports, how it's supported, how it's how those chip selects are driven there, and it's buffered. And it's got the ability to detect there's no card connected there via some 10k pull-up resistors. The final part there is quite interesting, that IDE A0/1/2 connected to CPU A9, 10 and 11, providing 512 byte separation of registers to allow for move M trick. So I'm not sure if that is why it's faster than the 536, or whether that's some additional trick to do with the move M opcode, I want to say, because I think that's what that is, and it's, I don't know, it's trying to copy a certain amount of data across. There's some optimization going on with some instruction or something there, I think. So a massive thanks to Matt Harlum. He's done an amazing job with this. It's absolutely incredible. Love it. Really fast, really nice performance. And as you'll see in the next part, I've got a few more of these to show you in the next part. And we'll do a little bit more tests and stuff. So I do hope you found the video interesting. If you'd like to support the channel, please do the Coffee and Patreon links down below. I'll catch you in the next video.